Here we do something about the functional groups. There are various functional groups. I have written these here, few of these, and few in the later part. So the different columns of these functional groups are the family of the class or family of organic compounds, that which family we are having. Functional group, the name of functional group, its chemical formula. In IUPAC name, what will be its name if it is taken as a suffix, prefix, and what will be its name in IUPAC name if it is taken as a suffix and afterward an example. So first of all, we at alkane. In an alkane, there is no functional group. There is no active site. As if we say a functional group as active site, if we consider a pentane, pentane has 5 carbon atoms and 12 hydrogen atoms. All carbon-carbon bond and carbon-hydrogen bond are of same length, same polarity, same bond distance. So there is no any one site which is chemically active or reactive. So all alkanes are considered as paraffins because of their less reactivity. They have no functional group or active site. They don't have active site. So their chemical formula is C, single bond C, and 3 other single bonds. Their prefix will be alkyl group. If a compound has alkyl group in the side chain, so its prefix will be alkyl group. If a compound has a functional group which has low priority than alkane, then its suffix will be alkane. For example, if we have here ethane, so we write here ethane. So its ethane here we have taken is as a suffix. If we drop one hydrogen, it becomes ethyl, and ethyl will be the side chain of the compound. So the second functional group is alkene. Alkene has a double bond, this carbon-carbon double bond. So what is the difference between this single bond and double bond? Here it comes a pi bond. Here all bonds were sigma bond. Pi bond is weaker than sigma bond. So presence of this pi bond, if we have one pentene, so double bond is between first and second carbon, and all remaining 3 carbon atoms are inert. All chemical reaction taking place at this site. So in alkenes, that site is active where there is double bond. So this double bond is active or reactive part of alkenes. So their name, when they are prefix, is alkenyl, when they are suffix is alkene, and their example is any, say we take an example of ethene. So presence of this double bond implies that the compound is an alkene, and this double bond is the reactive site of alkenes. So alkynes has a triple bond. If you see carbon-carbon triple bond in a compound, you see the functional group or the reactive site, and that compound will be triple bond. So the family of this compound are called alkynes. So now if alkyne is present in a side chain, then its prefix will be alkynyl. So alkyne, we will drop E and add yl. If it is a suffix, then we write, say, ethine, HC triple bond CH. So this triple bond ensures us that the compound is an alkyne, and the active site in this compound is that triple bond. So if we have 3 hexyne, so the third and fourth carbon which are bonded through the triple bond, that is a functional group, that is active site, while the first, second and fifth, sixth carbon atoms are inert. Alkyl halide. Alkyl halides are generally represented by Rx. I told you before that organic compounds has two parts. One is alkyl group and other is functional group. So halogen group is represented by X. So if X, this X may be fluorine, chlorine, bromine or iodine. So X means halogen. So if you find any halogen in an organic compound or with any hydrocarbon, so the functional group will be halogen, and halogen could be chlorine, bromine, iodine. They are always taken as prefix, they don't have any suffix. So while naming these, we always use their prefix. So halo means if fluorine is there, we write fluoro, chlorine is there, we write chloro, bromo and iodo. No suffix, there is no suffix, so they always comes in as a prefix. For example, CH3, CH2, CH2Cl. So this is what the first carbon, as it has functional group 1, 2, 3. We say 1 chloropropane. So notice that chlorine became chloro, and chloro is a prefix. So the alkyl halides functional groups are always considered as prefix. Now come to alcohol. Alcohol has hydroxyl group, OH group. This group, OH group, if you see OH group in an organic compound, the functional group will be alcohol. So alcohol, if it comes as a prefix, means if there are two functional group, one other functional group is at the high priority and alcohol is at the low priority, the prefix will be hydroxy. And if the alcohol is at high priority or only OH group is present in the compound, we use its suffix as ol. For example, CH3, CH2OH, butanol. This ol implies that this compound has, this is ethanol. This ol implies that the compound is an alcohol. For the same reason, amines. Amines has amino group. Amino group is NH2 group. Their prefix will be amino. Their suffix will be amine. For example, CH3NH2. It can be written in both ways. It can be aminomethane or it can be methanamine. So we can use amino with alkanes as a prefix as well as suffix. So if you use as a prefix, it becomes aminomethane. If you use as a suffix, it becomes methanamine. So both things we can do. So here we move towards the second part of functional group. Stay with me.